Hello, today we're going to be talking about recursion in competitive programming, and specifically we're going to be talking about it within Python. So recursion is basically when a function calls itself within the function while the function is running. So it looks something like this, basically. So basically here, the function is calling itself. So if you call this function, then this function calls itself, and in doing so, it calls itself again, etc., etc. And it would theoretically run forever, but in Python it doesn't. So let's try calling this, and then let's try to run it. So as you can see, there is a recursion error. So this is because in Python there is a recursion limit, and we can check this out by importing the sys or system module. We can do get recursion limit. So basically with this we can see what the maximum recursion limit is, and as we can see it is 1000. So what this means is at most a function can call itself 1000 times, and then it raises a recursion error. And we can change this recursion limit to say with set recursion limit to say 1200, then you can see the recursion limit changes to 1200 or 1200. And doing this could be a little dangerous if you're going like much higher than 1000, say like a million or something, because that can maybe destroy your computer or just cause a bunch of lag in general. But yeah, the default recursion limit is 1000, so at most a function would be able to call itself only 1000 times, and then it raises an error. So then how can we use recursion in practice? Like a function calling itself, okay, pretty cool, but where can we use this function? Actually use it. So it turns out that a lot of recursion can be used in a lot of places. It's also a part of dynamic programming, and we can see an example with the Fibonacci sequence. So the Fibonacci sequence, if you've learned, is a sequence of numbers where it starts off with 1 and then 1, and then you find the next number by taking the sum of the previous two numbers. So in this case, the next number would be 2, since 1 plus 1, right? And then after that, it would be 3, since 1 plus 2, and then 5, and then 8, and then 13, and then 21, etc. So we can use the Fibonacci, or we can use recursion if we try to find out what is the number at a specific position in the Fibonacci sequence. So for example, we can theoretically, if we write this function, if we input 4 as in position 4, it should be able to output 3. So let's see how we can do this. So let's create a new function called fib, because Fibonacci, yeah. And firstly, let's build some conditional statements to weed out some baseline cases, I guess. Because how this is going to work is if we input any Fibonacci number, then it's going to calculate it's going to call itself for the previous two positions, and each of those positions is going to call the previous two positions, etc., etc., until it gets to the 1 and 0 positions again. So a little bit hard to explain, but so we can go right ahead and write. First we have to add a parameter. So if number, actually let's not call this number. let's call this position. So if the position is 0, that is to say, there should be like a 0 here, or let's just write this down. So essentially, the position 0 would be 0, and position 1 would be 1, and then position 2 would be 1, etc., etc. So if the position is 0, we are going to return 0 because the number at position 0 within the Fibonacci sequence is 0. So we return 0. And then if the position is 1, we return 1. Because it's not going to be able to find the 2 previous ones because we're going to go into negative numbers. So yeah. And then after that, if we go to position 2, we can do it without if else conditional statements because we have 2 numbers in front of us, and the 2 numbers are both caught here. They're hard to explain. And then since if it is 0 or 1, it'll have returned by now. We can write Alright, so let's see what's going on here. So let's say we try to find the number at position 8. So as we can see, it passes through all of this, and then it tries to find the number at position 8 minus 1, which is 7, and 8 minus 2, which is 6. And it tries to find whatever numbers are at those positions. And then it adds them together, and then it returns it. So, and then say we want to find the number at position 7 and position 7. That is calculated by taking the sum of these 2 numbers, etc., etc., and it all eventually falls back here. And when we try to find the sum of the 2 positions before this position, then we get 0 and 1, and thus getting 1. So it's basically going to call itself over and over again and create a bunch of recursive calls until it gets to the first few positions. So let's try this out. Start with a small number. Alright, so after a few recursive calls, it comes down to 2, which we can see is the correct Fibonacci number at position 3. And if we try to do, say, 8, then we can see that it returns 21. However, this function, it's going to take like a lot of time if you go with higher and higher number, higher and higher inputs. Not to mention, it's going to exceed the recursion limit. And in fact, if you've watched our video on time complexity, this is actually, in terms of big O notation, time complexity, it is 2 to the nth power time. So this is going to take a lot of time as you put bigger and bigger inputs. And so say, look, if we try to do like fib of 15, that takes like a split second more. And if we do fib 20, alright, still going here. But if we try, the point is, if we try bigger and bigger numbers, it's going to take longer and longer, and eventually hit the recursive limit. Alright, so this is basically recursion. And in dynamic programming, recursion is one of the tools you have at your disposal. However, you gotta be careful when you try to do recursion, because if you exceed the recursion limit, obviously that's gonna cause an error, so you might want to try to optimize it so that the number of recursive calls is below 1,000. Or you could just use languages that don't have recursion limits, as far as I know, like C++ or something. Now, a little trick that you can do when you're doing stuff that involves repeating a bunch of calculations, because in this case it does repeat a bunch of calculations because look, so say we want to find the number at position 8. Now we have to find the numbers at position 6 and 7, but to calculate the number at position 7, we have to calculate the number at position 6 and position 5. And here already calculating the position at the number at position 6, this calculation takes place twice, and this is going to like snowball when we get to the numbers earlier in the sequence. So to kind of like cache the calculations, we can use a little module named functools. So we can there is something called cache. So we can do this. So there is something called Lru Cache. So I think that's called least recently used, and that basically caches the most recent calculation done. And you can also use just cache. And see, if we do this with the cache decorator, then we can see it actually takes much less time. So we can try this with, all right, let's do this with 50. So you see with this, let's time this. So you see with this decorator, it only takes a split second, but without this decorator, let's see, it doesn't even finish at all, and it's gonna finish after a few moments, but we're not gonna wait. So this basically stores some of your calculations previously done, I guess, and if you use Lru Cache, you can just specify a number. I think this is how you use it. So if you put like 20 here, then that's remembering the last 20 operations. So yeah, so this will save you some amount of time when it comes to recursion and just a bunch of calculations repeated over and over again with Python. So yeah, this has been a brief introduction to recursion and competitive programming in Python, and we also talked about a neat little decorator, two neat little decorators called Cache and Lru Cache, and I hope you learned something one way or another. Goodbye.